Welcome. In this video, we're going to give introduction to the integration by partial fractions. Now, what is a partial fraction? Now, sometimes when solving integrals, we come across integrals that are in fractional form, and the level of complexity they present to us as they are is very high. So what we do is, because we cannot find an easier way to solve them, we decompose them into different fractions, and then these fractions are simpler portions of that main integral, and then we're going to combine the whole value of these different small fractions, and whatever the value is going to give us is equal to the value of the initial fraction. So you have a very complex fraction, and then what you do is divide into smaller fractions, and then you find the integration of each part of those smaller fractions, and then you combine the result and you get an expression or a result that is equivalent to the result that would be for that initial fraction. So we know that from our primary education that if we have, for example, 2 divided by 5 plus 1 divided by 3, this is going to give us 1. We do the LCM over here, and then what we can do is we can take 3 to multiply this side, and then take 5 to multiply this side. So what we'll do is we are trying to get the common denominator. So 3 into 2 is going to be a 6, and then this is going to be 5 into 1, this is going to be 5, and then this is going to be 15, which is 3 into 5, 15, 5 into 3, 15. So what you get here is a common denominator, and then we're going to get this expression here divided by 15. So this whole method of integration is based on the principle that we have applied over here. So here what we do, we have partial fractions. This is a partial fraction, this is also a partial fraction, and then these two partial fractions actually have a value that is equivalent to the value of this fraction here. So in integration by partial fractions, we have this, and then we want to come to this and then solve each one individually, and then whatever the result we're going to have here, we're going to combine it, and this result should be equal to this one. So let's solve an example. Say for example you want to find the integration of 6 divided by x squared minus 1 dx. Fine. So you know that this here is a constant, but this is a polynomial expression here. One thing that you should notice is that most of the times we're going to have this as a polynomial expression, and if it's not, it's just going to be a factorized form of a polynomial expression. So the first thing we have to try to find is the order of it. For example, this one is 2, right? This is 2. This means what? This means that we're going to expand this or decompose this given fraction into 2 smaller fractions, functions, which are partial fractions. Now this can be represented as 6 divided by the factorization of this thing gives us x plus 1 into x minus 1. If you multiply this into this is a square, and then this is going to be minus x, then this is going to be x, then they cancel each one, and then 1 and 1 becomes minus. That's why I'm going to get this here. So this is the first thing you do. Always you try first and foremost to do this factorization. After finding the factorization, where we are still here, and we're trying to come to this initial situation of small fractions. This is what we get now. Now the next thing that we have to do is that we have to transform this into partial fractions. So we can take this expression and say this is equal to, we can take it from here, say that 6 divided by x plus 1 to x minus 1. This expression can be replaced by some expression that has a value or constant. A divided, we can take one of them here, x plus 1 plus another going to be x minus 1. So this is what? This is as if it were this, and this is as if it were this, right? So what you're going to do here, you then have to try to find our LCM again. Now the main point of this is that we cannot predict what were these values when we depart from this point. We don't know exactly which value was here, which one was here, but we know that it was a constant. That's why I'm having here a and b. Fine. Good. Now we are establishing here some correlation. We're saying that this is equal to this. So this expression is equal to these two partial expressions over here. So the next thing that we should do is to find out LCM, so that what we're trying to do is to find a common denominator. So we're trying to do this step over here. So this is going to be 6 divided by x plus 1, x minus 1. This is going to be equal to, you know, in this what you're going to do, you're going to put here x minus 1, and this you're going to put x plus 1. So this is going to be what? This is going to be a into x minus 1 plus b into x plus 1. All of this now is going to be divided by x plus 1 and x minus 1. So that's what you get here. So the next thing that you're going to do is have 6, and then it's going to be x plus 1, x minus 1, and then this here was divided. When it comes to decide to start to multiply, so we're going to have x plus 1, x minus 1, right? So this is going to give you a x minus 1 plus b x plus 1, right? So this and this you can just simplify them. So you're going to have here 6 is equal to a into x minus 1 plus b into x plus 1, right? So this is a constant that we don't know. This is another constant that we don't know. If you find these constants here, we are going to replace them here, and then we can find the equivalent expression to separate this. So now the way that we have to find this thing is this. We have to find a value, a random constant for x, to try to solve this thing. You can find in various ways, but one of them is just try to find a value of x that if you put this value of x here, it's going to nullify one of these constants here, a or b. So in our case, let us take, for example, let's take x is equal to 1. Why am I choosing 1 here? I'm choosing 1 because if I put 1 here, it's going to be 0, which means our a is going to become, this part here is going to become 0, and I'll be able to find out this part over here. So you're going to have 6 is equal to, here you're going to have 1 minus 1, 0, so this one disappears, is equal to b into x is 1, so going to be 1 plus 1, 2, b into 2, so b is equal to 6 divided by 2, which is equal to 3. So we already have the value of b. Good. Now we have to find, we have to make another assumption, and then now we don't have to respect any specific order because we have only one constant to find. So we can choose any x, but it's always good to choose a very small number to simplify the calculations, right? So let x is equal to 0, right? We already have the value of b here. So we're going to have here 6 is equal to a into 0 minus 1. So this is going to give us minus 1. Plus, here we're going to have b into 0 plus 1. This is going to be 1. This is going to become plus b. But you know that b is equal to 3. So this is going to be replaced by 3. Right? So then this is going to come to this side. We're going to have 6 minus 3 is going to give us 3. So 3 is equal to minus a. Therefore, a is equal to minus 3. So we found the value of a and we also found the value of b. So what is the next thing that we have to do? The next thing to do is we have to replace these values from this given expression here. So what we're going to have here is the expression 6 divided by x plus 1 x minus 1 is equal to, what is a? A is minus 3, is equal to minus 3 divided by x plus 1 plus, what is b? B is 3 divided by x minus 1. So now we have managed to take this main fraction here and convert into partial fractions. So we managed to come from here to here. So this is something like this. Fine. So in our integration now, we're going to do integration of minus 3 divided by x plus 1 dx plus integration of 3 divided by x minus 1 dx. So we are replacing all of this. Let us put this in equal here. So we are coming all the way from here to here. Why? Because we are replacing this expression by this one here. And when you have sum or subtraction of functions or addition subtraction of functions, what you do, you can find the separate integrals of all of them. So that's what we're doing here, find a separate integral of this and of this one here. Now, as you can see, this is going to be equal to, this is constant, so comes outside, minus 3, and then here we're going to have dx divided by x plus 1, and this plus, this 3 is also constant, so it comes out, integral of dx divided by x minus 1, right? So this is going to be equal to minus 3. Now if you see this, we can try to use here substitution u to solve this thing over here. How? Let us come here, let's take these things and bring them here. If we take u is equal to x plus 1, it means that du is equal to dx, while derivative of x is 1, so we're going to have 1 dx, which is dx. Great. Because we're trying also to find all at the same time, let us take this one as u to use u du, but here also we're going to use substitution u du, but just to avoid confusion, let us call this w. So we're going to say that w is equal to x minus 1, right? Because if you say u again, we're going to have u is equal to x plus 1 and u is equal to x minus 1, which cannot be true. So dw is equal to what? Dx, because this basically is the same thing. So this is going to be minus 3. Now here dx is du, so this becomes du, x plus 1 is u, so you have du by u plus 3, and this is going to be what? This is dw and this is w, right? As you can see, this is basically substitution u du, so this is going to be equal to minus 3. Now this integral here comes from what? This comes from logarithm, so this is going to be natural log of u plus 3 natural log of w. Logarithm integration of this is log, integration of this is also log of whatever is here, right? But this function is just in terms of u and in terms of w, but our original function was in terms of x, so this is going to become minus 3 natural log of, what is our u, is x plus 1 plus 3 natural log of x minus 1. So this is our result, but then we can just try to rearrange it in making 3 natural log of x minus 1 minus 3 natural log of x plus 1, and this is our result. Now I can take this 3 common, but this doesn't change anything in our case. So this is how we solve using integration by partial fractions.